Science channel.
Today we will bring you a video, titled, What Happens If You Get Coronavirus, Covid-19.
This is SARS-CoV-2. It belongs to the family of coronaviruses named for the crown-like spikes on their surfaces. SARS-CoV-2 can cause COVID-19, a contagious viral infection that attacks primarily your throat and lungs. What actually happens in your body when you contract the coronavirus? What exactly causes your body to develop pneumonia? And how would a vaccine work? The coronavirus must infect living cells in order to reproduce. Let's have a closer look. Inside the virus, genetic material contains the information to make more copies of itself. A protein shell provides a hard protective enclosure for the genetic material as the virus travels between the people it infects. An outer envelope allows the virus to infect cells by merging with the cell's outer membrane. Projecting from the envelope are spikes of protein molecules. Both a typical influenza virus and the new coronavirus use their spikes like a key to get inside a cell in your body, where it takes over the cell's internal machinery, repurposing it to build the components of new viruses.
What exactly causes your body to develop pneumonia?
When an infected person talks, coughs or sneezes, droplets carrying the virus may land in your mouth or nose and then move to your lungs. In a healthy body, a hair structure called cilia constantly push the mucus and germs out of your airways, where you may expel them by coughing. Normally your immune cell system attack viruses and germs that make it passed by mucus and cilia. If your immune system is weakened, like in the case of coronavirus infection, the virus can overwhelm your immune cells. Once a spike on the virus inserts into a receptor molecule on your healthy cell membranes, acts as a key in a lock. This action allows the virus to get inside your cells to the nucleus that houses all your genetic materials. A typical virus would travel inside the nucleus, but the coronavirus doesn't need to enter the nucleus of the host cell. It can directly access to parts of the host cell called ribosomes. Ribosome uses genetic information from the virus to make viral proteins such as the spikes on the virus surface. Then some structure in your cell carries these spikes in vesicles that merge with your cell's membrane, the cell's outer layer. These spikes use your cell membranes to create a new virus. Then a new virus comes out of the cell membrane. Then your bronchioles and alveoli become inflamed.
Pneumonia may cause difficulty breathing, chest pain, coughing, fever and chills, confusion, headache, muscle pain, and fatigue. It can also lead to more serious complications. Respiratory failure occurs when your breathing becomes so difficult that you need a machine called a ventilator to help you breathe. These are the machines that save lives and that medical device companies currently ramp up production for. Whether you would develop these symptoms depends on a lot of factors, such as your age and whether you already have an existing condition.
And how will the COVID-19 vaccine work?
The push to develop a coronavirus vaccine is moving at high speed. Studies of other coronaviruses led most researchers to assume that people who have recovered from a SARS-CoV-2 infection could be protected from reinfection for a period of time. But that assumption needs to be backed by empirical evidence, and some studies suggest otherwise. There are several different approaches for a potential vaccine against the coronavirus. The basic idea is that you would get a shot that contains faint versions of the virus.
A vaccine as a preventative approach. There are multiple approaches to vaccine development to prime the body's immune response to COVID-19. Using weakened viruses or viral proteins, or creating viral vectors with specific viral genetic code. Or using specific viral genetic code, either DNA or RNA directly. Viral vectors are engineered to prevent them from being able to replicate and cause disease, but can carry specific genetic material to deliver inside a cell. The vaccine is introduced into the body through injection. Encompassing the genetic material of the SARS-CoV-2 spike protein, the viral vector binds to the cell surface and fuses with the cell. Inside the cell, the genetic material is processed to form the spike protein, which is expelled out of the cell and into the body. B-cell and T-cell lymphocytes recognize the spike protein as foreign and start to multiply to form an army of identical B-cells and T-cells. B-cells release antibodies into the circulation to bind to the virus and neutralize it. T-cells help activate B-cells or eliminate infected cells. Both B-cells and T-cells form memory cells that are ready for when the body is exposed to the virus at a later stage. Upon exposure to the live SARS-CoV-2 virus, the immune response is primed to neutralize the virus and reduce the impact of disease.
The vaccine would expose your body to a version of the virus that is too weak to cause infection, but just strong enough to stimulate an immune response. Within a few weeks, cells in your immune system would make markers called antibodies, which would be specific for only the coronavirus, or specifically its spike protein. Antibodies then attach to the virus and prevent it from attaching to your cells. Your immune system then responds to signals from the antibodies by consuming and destroying the clumps of viruses. If you then catch the real virus at a later stage, your body would recognize it and destroy it. In other words, your immune system is now primed. Collecting evidence on whether this will be possible, safe, and effective is part of what's taking researchers so long to develop a vaccine. It's a race against time to develop a vaccine amid a pandemic. Each step in vaccine development usually takes months, if not years. An Ebola vaccine broke records by being ready in 5 years. The hope here is to develop one for the new coronavirus in a record-breaking 12 to 18 months. While all of this will take time, stay home if you can, to protect the most vulnerable.
Do the 5 help stop coronavirus. First, hands, wash them often.
And don't forget to wash your hands for at least 20 seconds and as often as possible.
2. Elbow cough into it. 3. Face, don't touch it.
Avoid touching your face.
4. Feet, stay more than 3 feet, 1 meter, apart. Social distancing. 5. Feel sick, stay home. We need to stay home if we want to save lives.
If you want to be part of the solution, get vaccinated. When you have 70 to 80% of the people vaccinated, you have an umbrella of protection over the community.
Remember, wear a mask wherever you go.
This is a matter literally of life and death. Please, wear a mask.
Masks are extremely important.
Mask can keep us safe.
Masks make a big difference. Together, we can help stop the spread. Stop coronavirus now.
Please subscribe and press the bell if you enjoy my video. More video is waiting for you.
Thank you for watching. I hope you enjoy my video.